going down that way.
Maybe 70%.
We're a lot further away from help here than we are just about anywhere else I've ever worked. Certainly, you know, we're several hundred miles from the nearest support, and there's no guarantee that that support could actually show up if we were to need it. So we have to be very self-sufficient for long periods of time.
I'm sitting here about 500 kilometers from the South Pole in the middle of Antarctica on a pile of rubble, a moraine that was pushed by that formerly huge glacier that you see in the background here. That's now almost gone, exposing everything that was transported in the ice, and that's exactly why down there we found about 300 meteorites.
If something out of this, all these samples turns out to be a Martian or a lunar sample, that's a very special thing to be involved with, is seeing that in the field. It's a little harder to identify Martian meteorites. They look very similar to some of the other asteroidal meteorites, but certainly many of the lunar meteorites are easily distinguishable. And to be able to see that on the ice and go, wow, that came from the moon, you know, and here I am, you know, being able to pick that up. When was the last time that we were on the moon to collect samples? The important thing about sending humans to the moon or Mars is the context from which the samples were obtained. And that's a very important scientific piece of information that is lacking with these rocks that we get here.
I'd set it on the ground floor.
One of the things that I think can be really incredible to hold is an iron meteorite, because they're solid nickel iron minerals. They're incredibly dense. They're about 3 times for size the weight of a normal rock you might pick up off the crust of the earth. And so just even feeling their mass, you know you're feeling something really different, but it's a natural rock that comes from, we think, the crystallizing core of sort of mini planets.
Are you ready to receive data?
Doing field work and having teams here in Antarctica will support future lunar exploration, and preparing not just the astronauts but the engineers who are going to be supporting the space missions, as well as the engineers who are doing things like designing the spacesuits. Future exploration using both humans and robotic spacecraft or robotic assists for humans is absolutely the way that we're going. And so we know that robots can explore planetary surfaces. What robots can't do really efficiently is recognize whether something is a meteorite or a terrestrial sample. And those are things that only human beings can do, and it has complete relevance to the way we might explore the lunar surface, for example.
So microtectites, you have a big asteroid that hits, and this one hit somewhere in Indochina or Southeast Asia. And it was so energetic that the impact was so oblique or so kind of angled to Earth that when it hit, it melted the Earth on impact, and then it traveled all the way to Antarctica. I mean, it's amazing how far this stuff travels. It's interesting, all the different missions that are happening now, to see how we can mitigate if there is an asteroid that is coming close, what we could do to kind of push it off the orbit a little bit, and how people are realizing that it's a real threat and kind of trying to figure out how to mitigate that threat.
Noch interessanter finde ich persönlich erstmal, weil es sehr relevant ist für alle Menschen im Prinzip auf diesem Planeten, ist, dass wir irgendwann mal vielleicht in die Situation kommen, wo wir die Erde von einem Asteroiden schützen müssen, der Kurs auf unseren Planeten genommen hat, und dann uns vielleicht eine Mission überlegen müssen, wie wir diesen Asteroiden umleiten, um ihn von der Erde wegzuschleppen zum Beispiel. Und da ist es sehr wichtig zu wissen, aus was diese Asteroiden gebaut sind. Was für Material das ist, mit wem wir es zu tun haben. Die Dichte, die Oberflächenbeschaffenheit, die Bruchfestigkeit, wenn wir da vielleicht einen Anker in diesem Asteroiden befestigen, hält der dann, und so weiter und so fort. Das ist sehr wichtig, und das können wir tatsächlich aus diesen Meteoriten ableiten, die wir hier in der Antarktis finden.
So what I would like to be able to do is get the terrestrial ages of the meteorites and then compare that to the age of the moraine. And the difference between those ages may give me some idea of what the transport time of the meteorite in the blue ice was between the time it fell and the time it ended up here on the moraine. So then the question is, well, how is it that in some areas we find hundreds of meteorites and in other areas we don't find so many? And so the answer is there has to be some concentration mechanisms. And the traditional idea has been that it's the movement of the ice sheets that concentrates these meteorites. The other thing is that, we've been out here and we've experienced a little bit of this, is that the winds are just horrendous. And so we know that for the smaller meteorites, the winds can push them along the ice sheets. And so we know that we find lots of meteorites in windrows and on these little moraines.
It's amazing to feel like I'm the first person ever to see this rock, maybe, or that piece of snow. It's really unique. I never thought I would do this, even a few years ago.
We're gonna be making breakfast tacos. All right, we have Christmas and New Year's dinner.
You want a cutting board? Okay. Now we have a food truck.
Maybe just do one without.
Use the same thing.
So Johnny, what do you want to tell us?
Presents!
Yay! Wow, more. Oh, that's 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Happy New Year!
Okay, January 11th, 1912, Amundsen. At last the weather has improved. After having snowed all day, it stopped. We did not expect this. The weather has improved gradually, and it seems if we have good weather in prospect. We are lying in the cairn at 84:15, and we'll reach our depot tomorrow.
Little tiny tent feels like a home. The more time I've spent here, the bigger and bigger the tent feels, and it feels like, like we're all family, and we've all become so close in such a short amount of time that it just feels normal.
Harvest rock. It looks like to me that it's gonna dump a lot of snow, or at least make it pretty unpleasant to come out here.